We create a new project to begin an analysis. First, we enter a name for the project, where to save it, and then the path to the segmentation script. Now, we enter a name for each input parameter as well as their ranges. Here, the parameters are named alpha1 through alpha7 and sigma, and they all range from 0 to 1. Next, we need to select an initial sampling of the parameter space. Here, we select 50 samples using a Latin hypercube strategy. The scatterplot matrix gives a live preview of where the samples will fall. Clicking on the Run button kicks off the sampling. A progress bar shows the status of this process. Tuner has detected new fields in the output file and wants to know what to do with them. Here, we want to minimize error 6, ignore count, and maximize the rest. Clicking the OK button brings up the project viewer. Here, we show the response values of dice 6 in the lower left matrix and error 6 in the upper right matrix. We use the Pareto view in the upper left corner to find an area of high dice 6 and low error 6. The color maps are interactive. We can compress them to filter out values below a certain threshold. We can also focus in on an area using the zoom view. For example, we can zoom in on the unfiltered error 6 values. Now that we're close to an optimal point, let's add some samples. By sampling where the overall error is high, we would be able to build up a good picture of the overall function. However, in this example, we're focused on optimization. High expected gain corresponds to a high likelihood of finding a global optimum. These radius sliders allow us to draw out an 8D box in which to place samples. We narrow in on an area of particularly high expected gain. Clicking on the Add Samples button brings up the sampling interface. We add 25 samples in the marked out space. Clicking on the Run button kicks off the sampling again. Here we show the updated model. In addition, the interface also provides histograms for the estimated response.